have a 10-bit on the PIC 32 in this class. I think they're working on some 12-bit ones. Okay, so there's another aspect to this, and I mentioned that this signal has to be changing. This known signal has to be changing fast relative to the unknown signal. And that signal is slowly changing. And we have our known signal that is changing fast. Okay, if our known signal is changing very fast and we're creating these little ramps, I'm going to approximate them like this, and then it comes back down to 0. Right? So if this signal is changing fast relative to this one, when it crosses, and I'm drawing this, it's exaggerated, I'm trying to draw this, right? It's going up at an angle, then it comes straight down, going up at an angle, comes straight down. My lack of precision in my arm makes it kind of not look like a sawtooth. Right? So it goes up, comes down, goes up, comes down, and so we cross here, we cross here, we cross here, and we cross here, and we cross here, and so on, right? So we're trying to sample this signal, and we're losing a lot of information here. We lose the information between the sample points. But we could kind of, if we assume that our known signal is going very fast relative to this unknown signal, then we could guess, right, that at these in-between values, this is probably what the signal is doing. Right? We can take a pretty good guess at it. However, if our ramp is going really slow, let's say our ramp was really slow. So the first time we cross is right here, right? And then the next time we cross is somewhere way over here, right? So now, what happens if we try to approximate the signal between here and here? A lot of information is lost. So if you're looking at a signal that's changing, you want to make sure that how often you're looking at the changes is much greater in speed than the signal that you're interested in. Actually, it doesn't have to be much greater, it just has to be twice as fast. Our known signal, or it's also called the sample rate. Known. Our sample rate. Has to be 2 times the unknown signal. To be able to approximate. It's better if it's much faster, right?